So let's get into the terminology. You've probably heard me, using a couple of words already that you're not 100%, familiar with. So it's going to be helpful if we can understand the language that we're talking. And definitely if you can, understand some of the terms that I'm using, then we can both be on the same page as we go further and further into learning about these tools. So first piece of terminology that we need to be familiar with are a thing called tokens. So tokens are the most basic units of an AI model, or more specifically, it's the smallest piece of text that a model can process. And normally we'll say that a token is roughly 4 characters, or 3/4 of a word in English. They use 3/4 of a word just as an approximation. So if I say that I have 100 tokens, generally I can get about 75 words, represented in them 100 tokens. So it's not exact, but it's just roughly equivalent. So at the lowest level, this text that we are passing into these models, it is chopped up into things called tokens. So an example of this could be hello world. Okay, and this is approximately 3 tokens. We got to remember that a space is a character, so that actually counts as one of the characters. So this might be split up HELL, and then the next token would be O space WO, and then the next token would be RLD and exclamation mark. Okay, so that would be roughly around 3 tokens just for 2 words. So these tokens are the thing that is actually being processed. So why does this matter? Well, we need to understand tokens because these models are limited on how many tokens they can process. So for example, they will have limits for input and output, and we're going to look at why that matters as well. But these things cost money to process these tokens through one of these models. So normally these companies that are creating these models will charge you per token. So, or normally, per 100 tokens or per million tokens or whatever their equivalent is. But a token will be something like $0.000001, and we can. That's why normally it'll be there's 20 cents for 1,000 tokens, for example. So we need to. This is very important in terms of the limit. We're starting to look at some of the limitations now of these tools because they're limited on the tokens that they can process, and then obviously the more tokens that you process, the more that's going to cost you. So this will help us when we're using these tools for things like long documents. So if I have a document that is 300 pages, and every word in that document is going to be split up into a 4-character token, then that's a lot of tokens. Okay, so it's going to help us understand the limitations of the tool, but also to manage our costs, because if we're using it for long documents, costs can ramp up really quickly, and if the document is too long, then the model might not even be able to process it in the first place. So what's the point of putting that through and it costing us all that money if we're going to get nothing back out? Okay, so this is something that we definitely need to be aware of. At the end of the day, really what we're talking about here is how much context you can provide this generative AI tool. If you are limited in how much you can speak to the thing, and then it's limited on how much you can speak back to you, then of course the context is going to be limited. And this kind of brings us on to the next essential term. This is what we call the context window. Okay, so we start with tokens. We understand that a model can just process tokens. So what is a context window then? Well, this is essentially the amount of information that one of these models can process at once. Okay, or we might think of it as the AI can remember this much at once, and we have to measure this window in tokens because again, that's what the model is looking at. That's what its unit of measurement is. It's tokens. It's not characters. It's not sentences. It's not words. It is tokens. So the context window itself, because our models are limited in the input and the output, both the input and output are known as the context window. So if I have a context window that is, let's say, 50,000 tokens, if my input prompt, okay, the input information that I'm putting into this, we call that a prompt. Okay, if the text that I'm giving the generative AI tool is, let's say, 40,000 tokens, let's say it's a really long prompt, okay, then that means that the answer that I can get back is limited to 10,000 tokens. Okay, because the tool can only process 50,000. If I'm already taking up 40,000 of that space, it only has 10,000 that's going to get back to me. And typically what these tools will do, well, they won't use the full context window because they'll assume that you have follow-up questions. So it needs to leave room for you to ask a second question, for example. So some of these models and some of the context window limitations, we could look at the ChatGPT 3.5. Now this is quite an old model at this stage, one of the first ones. GPT-3 I think was the first one that was released to the public, so 3.5 is pretty fast after that, and its context window was around about 4,000 tokens. So if we take 3/4 of that, if we think a token is 3/4 of a word, then we're going to get about 3,000 words. The next iteration then was ChatGPT 4, and this increased the context window depending on if you were a free user or a paid subscriber. But for the free users, it essentially doubled the size of the window. Okay, so that doubled the amount of words that we could process. And remember, this is the words that we pass in as a prompt and the answer that we get back out. We have to include both of them in this number because that is the entire context window of that model. For the paid subscribers, they went up to a lot more. They had 128,000, which is just under 100,000 words. So again, still quite limited if we're processing quite large documents. Okay, and this is what I mentioned earlier about Claude. Claude is quite a useful one and quite a popular one for processing large documents. And now hopefully you can see why, because Claude's context window is 200,000 tokens. Okay, or at least 3.5 Sonnet. Now this is an old model as well. You're going to see that this is a theme throughout this course, that by the time we have this content written, all of these models are now out of date, because this stuff is moving on so quickly. But back at Claude, I think is at 4.1 now. But if we look back at the 3.5 version, it had 200,000 tokens, which was again roughly 3/4 of that in words, so 150,000 words. So if I had a long document to process and the choice was between GPT 3.5 or Claude 3.5, well, it becomes an obvious choice, doesn't it, because of the limitations of the context window. Now, Google's Gemini they have really focused on expanding the context window as much as possible. And essentially this is 2 million tokens now that the latest version of Gemini Pro has, and Gemini Pro is the paid version, but there are even this Gemini 1.5 is now the free version, so even in their free version they've got 2 million tokens, which is about 1.5 million words. So again, if you're going to process, let's say 20 books of information, then you might need to go to Gemini instead. Okay, so the context window, this is why it is so important to understand this term. So practically, how does this one affect us? Well, larger context windows will let us analyze entire books, multiple research papers, or long conversation histories at once. So you're going to get to a point, if you're talking with ChatGPT 3.5, for example, that it's going to forget what you were talking about, because it's going to run out of context, and then what it's going to do is it's going to forget all of the current context, and it's going to start with a blank page. Okay, so it's not going to remember what you were chatting about, so you're back to square one again. So we'll look at that again when we get into the limitations and everything. But before we even do get there, it helps to understand that this context window is the limit on the tokens that we can process, and that includes both my input tokens and the output, the answer that I get back from the model. So some more key terms that you're going to hear and you might just want a bit of information on. So you'll hear me using things like large language model, or LLMs, and these are just our AI models that are trained on massive, really massive data sets of text. Large refers to the billions of parameters, okay, and parameters are just the internal settings of the parameter, or of the model, sorry, so that you can get the output that you're looking for given a certain input. So these large language models are the ChatGPT 4, the Claude, the Gemini, Llama, all of these kind of main players. These are all the large language models. But also we're going to see that like DALL-E, for example, where it takes text and converts it to image. The only difference really between that is that it has been trained on text data sets and image data sets. Okay, so most of these are large models, okay, or large language models, and the only thing that's changing really is the language itself. Okay. Prompt, you've probably heard me using already. This is the instruction that you're going to give to the generative AI tool, and the quality of your prompt will significantly affect the output quality. So there's this new term, in prompt engineering, and this is really the best way, or the skill of writing effective prompts to get the output that you want. And we're going to see, that a lot of the time this is a skill in itself, but a lot of the time whenever people are using these generative AI tools and they automatically think to themselves, this isn't any good, I could have done better myself, it's typically because they've put in a bad prompt. And if they had refined their prompt, if they had refined the instructions that they gave to the generative AI tool, then they would see that the output would be significantly better. It's this kind of old thing, rubbish in, rubbish out. And the same applies for these tools. Training data, this is the data set or the information that's used to train or teach the AI model. So this will usually include, it's mainly large data sets of text and publicly available text. So that'll be things like books, websites, online articles, or even in the case of GitHub Copilot, GitHub had a wide or massive collection of code repositories, so they were able to train their model on the code that they had. So models have a training data cutoff date. That's something we need to be aware of. Whenever they release, like let's say they have, the newest, the latest version of ChatGPT, they will always tell you that there's a cutoff date here. And what that means is that the training data doesn't know about anything after that date. So if my cutoff date was, let's say September 2021, then the Queen of England dies in September 2022. Well, if that's a cutoff date for the training of the model's not going to know anything about the Queen dying. Okay, so things like that, it's, again, we need to be aware of these limitations. Parameters, these are the internal numerical values that basically determine the AI behavior, and we get parameters by training. So the training data is used to update the parameters, essentially. So more parameters generally means more capable models, and ChatGPT 4 has an estimated just over 1 trillion parameters. So these, we talk about large language models, these things are getting, we need a bigger word than large. They are massive language models at this stage. Over 1 trillion parameters. The ChatGPT 3 had 10 billion. Okay, so you can see the scale that's going up here. We're going up a couple of orders of magnitude every iteration. Then we have, when we're talking about prompts and prompt engineering, we have things known as zero-shot prompts or multi-shot prompts. And this is just a prompt engineering technique. So zero-shot is usually a single prompt and no examples are provided. Multi-shot is where we will have examples, we will have output format, there's loads of different, more specific instructions that we give the generative AI tool, and this will normally give us a better response. And we call it multi-shot because normally it might take multiple prompts. You might not get it all just within a single prompt. Now, again, the tools are getting better and better, and this eventually we might get to a point where a single prompt will give you everything you need. But at the moment, these things aren't intelligent in the sense that we think. If I say, I want a list of the temperatures for the previous week, if I just give a generic prompt like that, it's just going to give me back probably a list of numbers. Okay, but if I say to it, I want temperatures, and then I start to give it examples, and I start to say this is the format that I want the output. So you're starting to be more and more specific. It's very analogous to going into a restaurant and just saying to the waitress, I want food. Okay, that's a really generic instruction, and what they bring out might not be to your taste. So it's the same if you go to one of these generative AI tools and you just be really generic, then it's going to give you a really generic answer. But if I went into a restaurant and I said, I want the steak, I want it, rare or medium to rare, you give it instructions on exactly how you want your steak cooked. So you just be more specific, then what the waitress brings out to you is probably going to be more to your liking. So it's kind of, think of it like that. If I'm going to give it a bad instruction, then it's probably going to give me a bad answer. So this is something, that, like I say, will probably become less important, but at the moment now, it's still important. And this is typically when you hear people saying, "Oh, that ChatGPT, it's not any good because I put in, I asked it for a certain thing, and what it gave me out was wrong." A lot of the times, like I say, that's really down to the prompt. It's not really down to the model itself. It's down to the instructions. If you haven't given it clear instructions, then you're not going to get a clear answer. So if we go into more advanced concepts, and I don't want to linger too much on these because this is where we usually can, lose people. But whenever you start to get into using these tools more and more, there are certain things that you want to have more control over the model itself, and this is where these more kind of advanced concepts come in. So there's things like temperature. Temperature is essentially the randomness of the model, or of the outputs of the model. So if we have a lower temperature, let's say 0, this normally goes between 0 and 10 or something like that, but anything higher than 1 is seen as really random or really creative. So if I want to put a prompt in and I want to get consistently the same answer, I will lower the temperature towards 0. If I want it to be a different answer every time for the exact same input, I can get a different answer every time if I put the temperature higher than 1. Okay, so again, this is a term that you're probably going to hear, so it's just helpful to know what they're talking about when they talk about the temperature of a model. Fine-tuning is really the process of specializing a model for specific tasks using additional training on the domain-specific data. So these will be, we have the ChatGPT model and it can summarize emails for me. Okay, so we can do kind of, a generic kind of task, but then GitHub Copilot is a version of ChatGPT that has been trained just specifically on computer code. So it has the underlying architecture of ChatGPT, and it has all of the data that it was trained on initially, but it also has the extra kind of domain-specific training on the code generation. So therefore, that's how GitHub Copilot actually works out to be a better tool than ChatGPT when it comes to generating code, and it's just because it's been trained on that additional task. Hallucinations are another term that you might be familiar with, and this is essentially when these generative AI tools create false or nonsensical information. And this is really basically an output of the way that the model works at the lowest level. So when we're training the model, what we're doing is, let's say I have a sentence, "This guy is." How we train the model is we say to it, "What do you think the next word should be there?" So it's trying to predict what the next word is, okay? Given a partial sentence, it's trying to complete the sentence, and that is how we can get these beautiful original content from these things. It's just from the way that it's trying to train on the data. But because of this, it will try and give you information that's not true. It makes things up. It essentially is it knows the context of your input, and it's trying to please you, and it's trying to give you something that sounds right, but may not actually be right. Okay, so hallucination is something we need to be careful of. These things can hallucinate. Now, again, as these models become more and more advanced, the hallucinations are becoming less and less, and more kind of niche, but they still happen. These things still make information up. So we need to verify that information. And then multimodal AI, this is models that can process multiple types of data. So whether that's texts or images or video or audio. DALL-E, as was an example earlier, where we went from text to images. So that would be considered a multimodal model because it can understand multiple types of information. Some examples of this would be ChatGPT 4 Vision, Claude with image analysis, or DALL-E, like I said. And this basically just enables richer interactions and use cases. So we can do more things, if we can process multiple types of information or multiple types of data.